Everything. Okay. You need to pick up USB. There's some up front. Come on in. Hi. There's some USB if you need it, but save classwork. Okay. All right. So 5 o'clock. We'll go ahead and get started. I'm a week late. I'm sorry. So welcome to CIS40A, Computer Network Fundamentals, aka Network Plus class. We have a full house in this class, so a couple dropped, a few people added, so we should have close to 50 students. So my name just be people. So in this class, you are going to learn computer components that you can use to configure in a network environment. We will do various things from configuring routers, switches, installing servers, configuring the servers throughout this course. So the time that you're here in class, we're going to do a little bit of concept lecture at the beginning, the first hour to 2 hours or so, and then we'll follow it up with some exercises so that way you can apply the concept. I do have test out license for this class, so I will activate that down the line. You can use it to do additional lab exercises if you need. And then we will do the practice exam for Network Plus. So my goal is for you to certify for Network Plus by the end of this class. So when you finish the course, if you need Network Plus voucher for exam, it runs about $350, close to $400. Without discount, let me know and then I can give that to you. Okay. I do have other certification. We just bought a bunch, like CASP, CISA, several. So when you take the courses, let me know if you need certification. So we'll also talk about IP addressing, IP version 4 and IP version 6, how to configure subnet and segment on the network, looking at protocols and services for your network environment. That's really important in cybersecurity. Okay. So we're going to do 1 day a week, which is Monday. We're going to go from 5 to 8 about in this room. And most of all our materials is going to be through Canvas. Okay. So you will check out your assignments and your lecture notes. I will have the video posted after today. I will try to get it up by tomorrow. So if you need to rewatch it, you can for lab and your lecture. Okay. So as we mentioned, we're going to learn about TCP/IP model. We are going to learn about OSI model. This is very important. Employers, they like to ask questions about this. And it's really good to know about this when you are troubleshooting, when you are assessing vulnerability in a network environment. I just went over the lecture with my Thursday class last week, and they have to look at security for the network architecture. So it's every layer of the OSI is essential in cybersecurity and in network configuration and troubleshooting. We'll learn about subnetting for version 4. I know version 4 is old, but it's still being used. So we'll go through the exercises and practice to do that. Now, if you go for Network Plus, they don't really require a lot of subnetting knowledge. They do ask a few questions related to this, but if you are going for the CCNA, the Cisco certification, you will be required to know how to subnet. And it's always good for network administration to know how to use IP addresses accordingly. So I'll do some exercises with you close to halfway through. We'll go through it as a class, okay? And then we'll talk about version 6. It's pretty much mostly automated, but we'll look at the format for version 6, how that's used in a network environment. I think most network now integrate version 6 and 4 for private addresses. So it's important that we know how to use version 6 address. Down the line, we are going to talk about routing. You will be using Cisco devices. I got some additional Cisco devices. So you will connect directly to a switch or a router to configure. We'll look at routing table, how to set up dynamic and static route. There is another class called routing and switch, CIS40B, which is the one following this, and it emphasizes this area a little bit more. And it focuses a little bit more on Cisco technology and other technology for routing and switching. But I want to introduce you to routing and also switching, and then we are gonna learn how to set up VLANs, which is virtual local area network. We use it quite a bit for segmentation in cybersecurity, and also, you know, if you want to isolate certain part of the network or separate or segregate certain part of the network, it's important. So we'll look at the packets and how it's used in routing. And then we'll touch on UDP, looking at user data protocol, and also how we're looking at the header and the payloads. And that's really important when you are monitoring a network for performance or cybersecurity. You will be installing DNS role on the server. So we will configure server 2019, adding the DNS role onto the server for your domain, and then also DHCP and other roles, okay? So I touched on VLANs and some other areas in switching technology already. If you want to get into VoIP, right, voice over IP, switching technology is essential, like layer 4 switches and up. Okay. For dynamic host configuration protocol, this is used to distribute IP address within the network. This is a role that we will configure for the server. So I'll show you how you can set up IP pools, be able to automate that through the server. So when the user logs in connected to your domain, right, DNS sees it, your authentication system acknowledge and provide the security token. Then if that system is connecting remotely, we want to be able to utilize a way to distribute the IP address so it becomes part of our network. So we'll look at how to control the leases, looking at the IP scopes, and then we'll talk a little bit about different cabling. I know some of you already did cable in the other classes, so I want to make sure that you can use some class time to be able to create your UTP. If you've done an Ethernet cable already, you can do a coaxial. I just bought a bunch of cable connection or connector. So we'll take a look at different types. I'll show you what different types of fiber looks like. We do have some fiber type of equipment, so you can take a look at that and how different type of fiber is being used in the network. And then we'll talk about wireless technology. Wireless is important. I think it's everywhere now. Hello, how are you doing? Take a see if you need a USB. There's some next to the snack box. Okay. Hi, come on in. And then we'll go into wide area network, looking at ISDN, DSL. This is older technology, also older technology. So when I first came into the field, when I was a field network technician, I installed a bunch of frame relays, right? We still talk about it today because some part of the world is still using old technology. There's some USB there if you need to save work. And then we'll go into topologies today. We'll take a look at how network design is important because some of you might want to become a network engineer, right? When security people, when they look at network security for the architecture, they actually talk to the network engineer who designed and redesigned the network. No, sometimes we cannot rip out everything and then reinstall everything, but what we can do is we can improve the network infrastructure on how we place things logically. So we'll take a look at how we can design a network today. We'll take a look at the network layout, like ring topologies, star, right, hybrid, tree, structure. So all of that's important because when you assess security, sometimes when you look at the network layout, you can see the flaws in how it's connecting. like HVAC is connecting to some part of your backbone, and that create a hole because someone can go through your HVAC system and get into your server system or other areas of your network. So we'll get into the logical map and the physical map of the network. This is important for even not outside of engineering, but looking at improvement in how we can utilize the information for performance purposes. And then mapping IP addresses back to VLANs. And a lot of it, when you're applying for network technician 1 or 2, most of it is troubleshooting and understanding the type of communication systems that are talking, right? So we need to take a look at how we can test network baseline, because we want in security availability 99.99999%. So performance for network is essential. So this is the core in cybersecurity knowledge, is the networking part. I can't emphasize that enough, right? And then we'll look at optimization, how we can improve our network performance, and then using ping. Now, ping services sometimes is not turned on for security reasons, but we would use ping to test and be able to see our communication response. Okay. And then we get into security, how we can implement some of the security practices and technology, and looking at authentication protocols, at which layer it's operating, right? Because sometimes encryption exists in transport. So that's before it gets to application, right? When you authenticate to pay your bills, all of that is already happening in the back. When your server is utilizing encryption to protect your password and all your data, all your payload is encrypted, that's already happening before the layer that you see on your browser. So we'll take, so in this class, you're gonna see the behind scene on how things are talking. You would see how the servers are actually connected and be able to understand a little bit more about the processes and what the user sees. And then we'll touch on the threats in the network and the vulnerabilities in the network. There's no 100% security in anything, right? And then we'll take a look at access management, which entail authentication, authorization, and accounting. Any question? Okay, so here's your learning outcome. You should be able to identify and differentiate devices, right? This comes up for jobs and different things. And we want to be able to look at data in the network and how data is communicated. We want to be able to derive solutions to resolve some of the network problems. We are in the business because people have problems, right? That's what we do, is to fix problems in cybersecurity, in IT, and networking, right? We're not in business if everything is operated and automated fine, right? Even with automation, we are in business to make sure that things go smoothly and fix the problem behind the scene. So you have to be able to understand and come up with various solutions to make sure that your network is well, okay? And then we want to design a network that is suitable for your business environment, because IT is money, right? Without IT, without your technical system and servers and network, there's no transaction with credit cards, there's no inventory, people cannot buy things online. So IT is money, okay? And you know, where your data is stored and where your data is maintained, right? That's where we work. And then we'll take a look at the protocols, right? These are rules that are utilized by different services. Could be for security reasons or communications. So we'll be able to understand and be able to explain the function of various protocols. Okay. Ideally, you should be taking some other classes before coming to this, but it's okay. Hi, come on in. There's some USB right there, and if you can find, I think there's a couple seats around the room still, so. If you have taken CIS1A, that should be adequate, but this class is for Network Plus. So all my students that took Security Plus, Network Plus, and some other certification, they all tell me Security Plus is the easiest one. That should be the first one that you should go for. Brandon just passed his Network Plus certification, right? Is that, yeah. It's one of the harder tests because it requires a lot more detail. So, because in networking, we have to remember a lot of different things, but you can pass, right? So ideally, after you take A plus, which is in CIS 25, or operating system class, you can go for the Network Plus, but you can, like Brandon, you can go for that first and then study for Security Plus. A lot of students pass Security Plus first, and then they struggle a little bit with Network Plus. But all you have to do is just be consistent with your studying, right, and reviewing, because in this industry that you have to memorize a lot of different things or know a lot of different details. Okay. All right. So this is the book that I use. You don't have to buy the book. If you want, you can. There are practice questions and practice exam in the book. Like I said, I will provide you with test out license, which contains a similar book. I reference this book for, notes and assignments and things. And the version for the test is the 007. I think they just phased out 006 in July, right? That was the cutoff for 006. Our exam voucher only goes for the new certification, which is 007, and that's gonna live for like 3 years. Hi, come on in. So, USB, there's some there, and then you can take a seat anywhere in the room. Okay. So I had students asking me for the older version of exam voucher. We don't have that because CompTIA doesn't sell it anymore. It's usually for the ones that had bought it a long time ago, but you have a year up until May to take the test. Okay, so we will do assignments in weekly when we meet. I think next week is a holiday, so you guys won't be here, and I won't assign anything for next week to hope that you enjoy Labor Day. But today we're gonna start with an assignment and lecture. If you submit a week late, I will deduct 10% from the earned grade. 2 weeks late, 20%. 3 week late, 30%. I like to not take anything after 3 weeks late. But sometimes life happens, but let me know in that case, right? Like I have students that have medical related issues. They have to be out for a couple of weeks, and it takes a little bit to catch up. So just let me know, I'll work with you. So we'll do class assignment. So if you get that done in class, you don't have to worry about it. But if you are not done in class, you can watch the video. You can turn that in at the end of the week. I'll have it due on Sunday. We will have a network praxis exam. I will turn this on after Thanksgiving. Okay. So you should have a good close to 2 months to be able to do it. Do not wait until the end to do it. Okay. You should try to do it and then go back and redo it so you can improve your score. But hey, if you're really good, you can get a high score off of the bat. Your goal is to get 80% or higher, and it is weighted into your grade. We will have a few quizzes throughout the semester. I do not give midterm exam. I have quizzes every few weeks and a final exam. Final exam is multiple choice. It's going to be released via Canvas. Okay. I will likely, maybe I won't use lockdown browser this semester. Seems to be some problems last semester, so we'll see. But I do not allow late final exam. If students are traveling for the holidays and things like that, just let me know. I can also turn on exam earlier. But because I have a very close deadline for grade submission, I don't allow late exam. Okay. And you would have most of the week, like Monday through Thursday, to take your exam. Okay. I've had student email me at 11:30 trying to take a final exam and close it by 11:59. Do not be that person. Okay. Because it will cut off right before midnight. And sometimes it takes longer for a person to go through the exam. It's going to be 50 questions, multiple choice. Any question? Yes. It's on Canvas. It's online. Yeah. So yeah, the final exam will be online. I will send you information about passcode if I use lockdown browser. If not, it's still passcode protected. And then you just have to input it and take the exam. We'll have extra credit opportunity. It never exceeds 7% of your overall grade. I do not allow late extra credit because, you know, it's just extra credit. So if you miss it, you will have another opportunity to do another extra credit. If you did all the extra credit, it might help lift your grade a little bit. I normally go through one by one and I look at the area. So if somebody needed a little bit of help because the final exam grade is lower than most and then all the other grade, the points will go there. Somebody missed a few labs and their lab grade is lower, I put the points there, okay? So here's my grading scale, standard college grading scale, no pluses or minus. Your goal is to get an A in this class, right? Okay, my classes, I'm pretty easy. So, you know, if you attend and you do the work, likely you're gonna get a good grade. Okay, quiz is gonna be 10% of your grade. Assignments and participation will be 35% of your grade. Your lab activities will be 20% of your grade. So we have this and this weekly. This is gonna be every few weeks. Your practice exam will be 15% of your grade, and your final is 20% of your grade, right? I've had a lot of students over the summer I taught Python, and they were like 99% with extra credit, right? The maximum I can give is 100%. So, you know, it's fairly easy. Just a lot of the times you just got to do the work and apply the concept. I do reserve the right to drop the student if I don't hear from the student, if the student is missing for about 3 weeks. Sometimes if it's farther on in the semester, I don't drop the students, the student will earn the earned grade. So if they don't do anything, attend class, but not submit anything, likely that they won't pass the class. And, you know, they will just get the grade that they earn. But if you wish to drop the course, make sure that you look at the deadline. I think that's coming up in a week or so. Otherwise, it becomes a W, which impacts your financial aid. I try to drop a student or give a student a grade at the end if they didn't get a good grade with an FW. So that way it doesn't impact too much of their financial aid, but be aware of that because if you have too many, you know, drops, that can impact your completion percentage, which impacts your overall financial aid. And when you transfer, it becomes a problem. So just be mindful of that. Okay. All right, just do your own work. If you have issues with other students or me, make sure that we address it. I follow the college policy. We have a grievance process where you can fill out a form that gets sent to the Dean of Student Services and also academic dean. If it's instructor related, you know, they will bring the instructor forward with the student. If student to student related, they will address that accordingly. Okay, make sure we do our own work. And then if you need accessibility, I think now it's called ARC, Accessibility Resource Center. They have Zoom hour, so you can communicate with them via Zoom, send an email or a call. If you need a combination like extended test time, right? They also have technology like screen readers and other things for you to do. But I do release notes, so if you need that, and I also have recordings with captions, so that would help, you know, if you need that. Yes.
It's ARC, like formerly known as
DSS.
Okay.
Yeah, it's renamed because the student body voted to be renamed. Disability, you know, DSS just sound very negative, right? So I like the new name. Here's my contact information. My office is no longer in PSC 21. In the last few weeks, with all the craziness, I had to move. I'm now at the makerspace. If you call this number, it goes to my voicemail, right? I'm usually here before class for office hours to help students if they miss anything. If you want to make an appointment, outside of office hours, we can do that. Best way to get a hold of me is to send me email. I will answer within 24 hours, if not promptly. Here are my office hours, right? So I'm in science technology, first floor. When you go through the sliding door, it's the group of office in the front, and I'm on the farthest left. Okay, so Monday and Wednesday before class, you can come in early if you need to catch up. Tuesday, I'm all virtual for my online class. Yes, question? Yeah, I can give it to you. Yeah, just make sure you remind me. Yeah, I know it's full, but I think I had a couple of drops. As long as can fit people in the room, it's fine. I think a couple of people are out, but we have enough seats, I think. For Thursday, I have a class on Thursday at 5, and I'm here before class, right? I'm usually here before class. If I'm not here, I'm in. If someone is using the room, then I'm gonna be in my office, but I'm usually here. And then if you can't make these hours because of work, send me an email. I do meet students on Friday sometimes. I'm here for meetings, and I can also Zoom if needed. Okay. So if I need to contact you, I will send you Canvas message or to the college email. I do respond within 24 hours unless I can't get connection or something's wrong. But any questions? Okay, so that's the syllabus. You can find the syllabus on Canvas, right? There's a syllabus page. We would use module, all of that, your textbook, my contact and office hours is also there. The syllabus is there. If you need Office 365, now you can log in with RCCD, right? But you can also download it on your system. If you need associate degree information for cybersecurity, it's listed there. Okay. And then if you want to make money for scholarship, I have a scholarship opportunity, $6,000 a year. You should apply, right? I'm looking for candidates or scholars right now. It's free money as long as you're full-time and you have good GPA, okay? And you're in STEM. Okay, so download our notes and then assignment and lab. We're gonna go through this, the notes and the assignment now. If you need the files, let me know, or your friends can also share that with you. Any questions? Okay, so the simplest definition for a network is any two computing systems or systems connected. A network consists of embedded systems, which could be used for automation, like robotics in the warehouse. Okay. Or it could be microcontrollers in a farm, right, to monitor water, heat, etc., for soil and agriculture purposes. So when you're at home, you actually have a network, right? You're connecting to your printer, you're connecting to your router because you have multiple systems connected together. So at least 2 or more systems, right, in a network. We can have it peer-to-peer, which is equivalent in role. Like if I need a PC with my laptop and I'm connecting directly to it, that's considered peer-to-peer environment. Not secure, right? We do that for file sharing purposes. Traditionally, that was what was done, right? Before I came into the field, a lot of peer-to-peer network. You might see this when people are using it for gaming purposes, but now we use client server environment where you are connecting to a server to authenticate so that way you have a centralized control of what a network would be. Sorry. Let me flip over to I get. So to answer the first question, it asks you, what is a network, right? If we need to tell an 8-year-old what a network would be, it will be just 2 or more computers connecting together. But why are we connecting these computers is to be able to share resources. Like I can share some photos with you, right? Sometimes if you are using your iPhone and connecting to your TV, that's a network, right? You use it to be able to stream, you use it to be able to communicate. So we do it for a reason, to share data, to access applications, right? To share connection. And in any of the combination, and you don't have to put it verbatim, you can just summarize what the definition would be. Okay, so 2 or more connected computers. Make sure we know that. Now with that, we would establish a local area network. So when you look at an IT job, right, you are looking for even support technician, network technician, they normally tell you, know how to manage a LAN, local area network. Be able to work with TCP IP, right? Have the knowledge with using TCP IP model to troubleshoot. That's really the core for this class. So a local area network is really restricted to the local physical location. You are sitting in a local area network right now, right? So anything beyond your router considered wide area network. So at home, you are in a small, right, home network, but it's local area network. So in a business environment, what you see is the local area network is restricted to the span of the location, the physical location of the building. We might have a tall rise building with many floors, right? The first floor is connecting to the second floor and all the other floors. So when you visit that type of business, right, you check into the reception and the supervisor office is upstairs, right? But they need to be able to communicate. Do you guys know what kind of cable is connecting from one floor to another? Do I use a coaxial? A coaxial is like your cable TV cable, the round cable with the needle. Do I use an Ethernet cable to connect one floor to another? Or another type of cable? What do you think? Ethernet is restricted to 100 meters. But the farther you are from the source, what happens? You have attenuation, you lose signal. When you have a lot of cables together, you also have a lot of talking. It's kind of like being in a very crowded place, right? I'm talking to you, you can't hear me because everybody's talking. So signals, when it comes together in a very crowded environment, you have signal intervention, interference. You use fiber from floor to floor. Fiber either use laser or LED lights, and we'll touch on that later. Okay. So in a LAN, you would see a lot of different media like Ethernet cable, sometimes that could be coaxial, wireless, fiber optic. That's very common now because it's fast and it's secure, it's stable. So in a business environment, in a local area network, you would have computers like desktops, printers, copiers. Those are all networked together. Copy machines have hard drives, right? It's connected to the network. You have to authenticate it sometime when you put in a PIN. You also have servers, mobile devices, because you got users that are connecting. Sometimes they would connect with their iPhone or their Android or their laptop. And all of this, we establish a network to do what? To share resources. That's ultimately the goal. To make sure the resources are available for the systems and the users. Because without that, there's no purpose in connecting them together, right? If you look at the internet as a whole, the internet is the purpose of that, to share information, to share resources to the world, right? And the internet is just a collection of all different networks connecting together. I'm connecting to Google domain, or I'm, to access my Google Drive. I can connect to social media like Instagram. So that's also its own network, right? Now, when you first install your system, let's say that you go to Best Buy and you buy a computer, like a laptop, you go home, everything is already installed, like Windows 11. You turn it on, right? And it walks you through how to connect it to the network. So the system out of the box, it's gonna be part of the work group. It sees itself as its own entity connecting to its peers. Now, when you come to school and you're sitting down at the computer and you're logging onto RCCD network with your email account, you're part of the client server environment. So in a work group environment, all the systems are equivalent in the role, right? I can share my files with you and I can control the files only. I cannot control you. So the downside in the work group environment is it lacks security association with one another. So with that, we just physically are on the same network environment. Like if I'm connecting my phone, I have an Android, right, to my smart TV, I can stream to my TV like watching a show, right? But truly, the two systems are equivalent in the level. It's just communicating by sending signal. In a server environment, you have to authenticate to it, and it grants you the type of access that's needed for the other system. So you have a lot more control in the client server compared to the work group. Question. So an example of this, you might have a departmental type of work group environment or your home network. That's really a work group environment, unless you have a server at home, right? For media purposes, I have a server where I have data, backup storage. So whenever that I'm connecting to my home network, it automatically syncs, just like how you automatically sync to your iCloud. It automatically sync my data, like any new picture that I take, any kind of downloads that I have, right? I automate that process, and then I can access it when I'm traveling. So if I need to find a picture that I had uploaded a while ago or synced a long time ago, I can. Just like how you can connect to your iCloud or your Google Drive to be able to do that, right? So in that case, that will be a server environment. Any question? Okay, I'm gonna flip back to the notes real quick. Okay, so let's talk about what a host is real quick. So anytime that you hear the term host, that's just a system, okay? It sounds confusing. Host could be a workstation, it could be a printer, it could be an appliance like a switch. It could be, a security appliance, just that's a host, just a system. Here's the workgroup information from your notes. So when we look at the server environment, the layout would be like this. I have the sales department, the marketing department. So the sales department is connecting to the hub where the marketing department is connecting to the switch. What's the difference between these two appliances? So a hub is simply a signal repeater, right? It is usually smaller. You can still buy it. So basically, if I'm on the first system here in the sales department, if I want to send data across? I can, right? However, the hub, it's not smart enough. So in the case where if there's issue with connection or error with my data, it doesn't care because it already repeats that signal and it's sent. Okay. On the switch, we manage our switch. So in the case if there's error, if I'm in the marketing department and I wanted to send some information to the sales, right? In the case if I have data error or I have connection issues, the switch, it either corrects the problem if we manage it properly, or it sends notification that it fails. And that's what we want. We want to have accounting and tracking in network performance. Okay. So in a very small environment, I recommend the hub. The hub should not be used in a larger enterprise scale or in a network for stability reasons. Okay. Now, so this is a little bit further down the line, right? So let's say that I want to isolate this part of the network from this part of the network. What we can do is we can use a more advanced switch or a router to connect and treating it like two separate networks and use different IP addresses. And that's how you can segment it. Okay. So we can take this and redesign. So the first thing that I would do, replace this with a switch. Okay. That's get one improvement, right? We have to take a look at the data from the server. So the security person, they're going to say what data goes here? How are these people authenticating here? How are these people connecting to these systems and these systems, right? Because there's no security in this segment of the network right now. Someone can go in and access this server, this server, this server, and this server, right? As long as I can get to the switch. So the switch is like your main street to your neighborhood. The router is like the exit, the freeway that gets you to your neighborhood. So the router routes the data to the exit. The switch is going to take that and take it to the road to your house, right? You notice that it's like this. So to get to, imagine that these are all individual homes. The switch gets to your little homes, right? The router gets it to the main street. Okay. So see how they place the router here? So when you do that, this becomes its own network. This becomes its own network, right? We can upgrade this to a switch instead of a hub. And then we can, so I can route back and forth. Okay. Any question? I think I touched on peer-to-peer already. So you can still connect to a hub, and that's going to be peer-to-peer. So where you sitting, a lot of the time we say PC desktop, right? In a business environment, a workstation, the hardware that goes into it is supposed to last 3 to 5 years with regular use. Those are client systems. The servers are the systems that has functionality in the network to either distribute or control resources, right? Provide services, hence the name server. So here are the different types of server. I think Microsoft called this storage server now instead of file. And then you have mail server. The majority of the businesses use Microsoft product, which is Microsoft Exchange, right? There are other products that are not Microsoft related, like in Linux server environment, but a lot of times Outlook is just more common to implement, and that is for Microsoft Exchange. So when you're logging on to your RCCD email, you're accessing an inbox in the mail server once you authenticated, and that's Microsoft Exchange. A print server controls print queues and print resources. But a print server doesn't have to be a powerful system. You can use a regular computer to control the print. So let's say that you want to make sure you monitor all the print jobs, like in a, if you go to Office Max or whatever, right? They have their service to print, right? And they have a server that control the copier and the printers and all of those things, because you have to pay to activate that particular transaction to be able to make a photocopy and etc. Right? So you can set that up for monetary reasons. But in a business environment, they do that so that way they can monitor, the ink cartridges, the service, the maintenance of all the printer and so on. And then there's fax server, application server, and then telephone servers. This is for data center now, or call center. Okay. So earlier I touched on WAN. What is a WAN? So a router, when we place that router on that network in the middle, right, it becomes a network. Separate the left from the right side. So the router is like a gateway to the network. So it's often referred as a gateway. So a WAN, it needs a router or a router port, and it spans in a larger geographic area. So when I would enter the WAN or the internet, sometimes you see the drawing as a cloud, right? So when we say cloud servers, what does that mean? It's just a server. Hi, how are you doing? You need USB, there's some up here. So a server that's connecting via the internet, right? It's just equipment that's placed geographic somewhere else at Amazon data center or at Microsoft data center for Azure. So in a larger geographic area, when I'm going from one network to the next network, or a collection of network, it's actually considered a wide area network. Anytime that you're leaving your private network. So think of it this way. Your home has a gate, right? And that gate allows you to enter or leave your home. So then think of your home as your local area network. So when I leave my gate, which is my router, and I step into the street, right? The public street, that's considered you entering the wide area network. You probably going into someone else's network now, or the road now, right? So internet service provider connecting all of these networks together to give us the wide area network. Okay, like Charter, Cox, Spectrum, right? This area is serviced by Frontier and Spectrum. And so when you hear the term distributed WAN, it is an internetwork that's made of a lot of different networks, a lot of computers in different places. So in an enterprise environment, it's a distributed WAN. For example, Bank of America, right? You guys go to the ATM machine here in Moreno Valley at one branch location. Maybe I'm on the other side of town. But let's say that you're traveling to Washington or another area, you're accessing ATM machines in the distributed, right, wide area network. Right? You put in your ATM machine and it updates your account. It's still interconnected, but through the wide area network, through many other networks, but in the Bank of America networks. Right. So when you're looking at an enterprise environment, a lot of the corporate, right, in the span of national company, you do see that they use the distributed WAN. So when you go and you look at your home network, anything, right, inside your network before your router, like I might have a game console, a couple PCs, smart TV, all of that is part of your private network, right, in your local area network. Now, when you go into the public, we say the internet, right, that is crossing into someone else's network. It's like going into public street or freeway. to go into other people's home and other people's network. Okay? Any question? So for quiz and exam, make sure we know what a work group is, a WAN, a LAN. So in cybersecurity, we often talk about proxy a lot, like reverse proxy. What is the purpose of a proxy? A proxy can do a lot of things. Most businesses use proxy to control how internet is accessed. For example, a school district like using proxy, right, to filter what the kids can connect. Like let's say, I don't want the students to watch YouTube when they're in the computer lab, right? I can use a proxy to do that. It regulates the traffic. It's kind of like, you know how you have a lot of cars going through, and if you put a police like checkpoint station right there, and all the cars have to be monitored as they go through that street. Yeah, that's a proxy. Okay, but proxy can be used to boost performance. So instead of going one way to connect to a certain area, I can have many ways. It's like having a lot of detours, right? So I can go this road, so you can have thousands of proxies, so that way the users can connect to whichever proxy that's available. But in security, when we look at that, we say, okay, what if we implement that for performance, but we monitor how people are using the system at the same time? Like, you know, if my users are accessing web application, I'm going to send it to this Google proxy. So that way I have to implement the right proper security solution. Whereas if they're just surfing the internet to look at YouTube or whatever, then I'm sending it to this Google proxy. So you can control it that way. It's just a way that we can diversify how the connection would be, right? But it just implement by using machines on the network for connection purposes to the internet. Okay, any questions? But the attacker can take that advantage for other reasons, right? So no implementation is without flaws, right? Okay. So let's talk about intranet and extranet. And companies like to have intranet for resources, like healthcare benefits, resources within the organization or enterprise. So an intranet is a network that is used for sharing information or collaboration. And it would have services for that type of organization, but it's only for the employees of that organization. Like you have to be a member of that organization to access the internet, because you have to authenticate to it, right? To utilize the resource. And an extranet is a private network that we can access by partners, by vendors, suppliers. So for example, AutoZone, they have many different type of products for cars, right? I can go there to buy windshield wipers, but I can also go there to buy brake pad, oil, etc., right? So they might have extranet to their vendors, people who produce the parts for certain brands, right? So for example, Walmart, they sell Disney products, Warner Brother products, and other products, right? Let's say that they have extranet connection to Warner Brothers for inventory purposes. So whenever, let's say that they, for Black Friday, they sell a lot of different things, and that item might be just really hot, and it's flying out of the door, right? So with that, if they do the proper database management at the people buying it online or in store, they would update it through the extranet. So basically, it's a private network that's owned by the vendor that's connected to organization or retailer like Walmart, Target, etc. With that, there's a limitation. Now, the security side of this, right? People say that a lot. Whenever you have vendor access or vendor connections, there's a risk because, you know, someone else can coming in from that route. So with an extranet, we also need extreme monitoring and the proper security implementation to make sure that we monitor that area, because that could be an external threat coming in. And the same thing with internet, right? You might have people who got key logs and then somebody logged in. So there's always a risk in any part of your network. Question? Think we touched a little bit on workstation already? Right? It is just a system for employees. Usually the system has a little bit better hardware than what you normally see with the regular computer, but most of you are using gaming PCs. In this room, we have gaming PCs, so it's, you know, so the adequate implementation for workstation, if you look on like Dell, HP, buying a workstation is higher in price than buying a regular PC for use, right, for consumer. Because it's for extended use on a daily basis. The lifetime of the system in the network, we normally, with regular use, like the maximum is normally 5 years on the daily use. And sometimes 3 years if it's short span. So you have to maintain and keep it warranty for 5 years. And then you, at the end of life, you have to phase it out, right? You gotta make sure that the data is secure and then the data is off of the hardware before you actually drop it out. So on the next part, we talked about different roles of servers already, and you can grab that from the notes or you can just summarize some of it. You only need 3 or 4. I put all of them in there. We talked about file server already, print server, a web server, right? A lot of students get confused about the web and the domain. So when you visit a website, right? Let's say that I go to Amazon.com. The landing page that you see with all the products and Amazon, so Prime Day, buy now, discount, all of that comes from the web server. So the web server, its job is to service you, to give you your application, your browser, the things that you see on screen. In HTML, JavaScript, PHP, etc. Okay. Now, a web server always, its partner is a DNS, a domain name server, hence Amazon.com. That's a domain. I cannot have a website without a domain, right? And my website won't load any kind of proper pages without the web server. So the web server gives you that HTML page, the prettiness, the interaction, right, with the JavaScript and all of the coding that could be also, you know, so when you're playing web application games, right, you're using web server and a domain, and then authentication server when you're logged in. So the web server is for web-based activity for HTTP or HTTPS. Hence, when you type in the URL, right, you connect into that web server. What's your name? I'm sorry, say it again. Last name? Okay. Yep. Okay. And then people are still using fax. Why are they still using fax? California has wet signature rules, right? I mentioned this several times in other classes as well, where you have to sign your regular signature. You cannot digitally sign. I think now with remote work and things like that, we are a little bit more flexible. But when you do loan contracts, mortgage contracts, things like that, contractual based, every state has different regulation and also federal have different regulations, so people still require fax. And we can digitize it, yes.
You might go back to upload a little bit.
Yeah. So when we say these servers, these are just roles that you can install onto the server system, right? It's a powerful computer, and the operating system for it is also different than your regular Windows 11 and so on. And then we have application servers that will manage network applications. So I can manage how the users are using the application, what kind of applications is integrated in my network through the application server. And this is crucial because you don't want the user to install a bunch of things. They should not be installing a bunch of things, right? The image that comes on the workstation would have the application that they need. And if you're using web application server, which is 99% of most websites that you see out there, whenever that you go on a website and you know, let's say that you want to pay for your credit card or you know, you're accessing a certain domain to authenticate to do things, right? Bill processing is the common thing. Web application is what you see, where you have a menu and then you can process the transaction, schedule a payment, you can look at your balance and so on. That's a web application. Now, application server can also be native control. Like, let's say that I don't want the user to use a certain browser on their computer. I can control that, right? So the resources that mainly manage the network applications. Or if I want to manage how like antivirus is ran on the network and on the systems. And then we'll talk about proxy, but telephone type of server, this is for call center. It's mostly for call routing, and we use voice over IP now that can be managed with the switch configuration. So AI is integrated in everything, right? Like now when you call for customer service, the first thing you get is AI. It asks you what you need and then it tells you, right? So with that, like today I had to talk to T-Mobile, and when I called their 1-800 number, I got their AI, right? It asked me, oh, it tells me what I kind of service I have, and here's some recommendation, what do I need? So I speak to it, and in the back, the telephone server actually routes me to customer service for that area. So it is intuitive enough to be able to send you to the proper area, but we need to configure that with the telephone server and the network environment. So when we talk about hosts, like I said, any system that could be laptop, tablet, server, workstation. POS is point of sale system, right? When you put in your credit card or you tap it, point of sale system. And all of these systems use what for communication? TCP/IP, transmission control protocol, and internet protocol. The IP is for addressing purposes. So at home, when you're using your network to play games or downloads or listen to music or chat with your friends, etc., or Zoom, right? You're using IP addresses inside your network, right? 192.168.0.x. And leaving your router, you have one public IP. It's kind of like at home, they call you all kinds of nicknames, and you know my that. But when you go to public places, you only have one legal name, and it's tied to your social security, and everybody in the world identify you with that public IP or that public legal name. So the IP address can be private or it can be public. It's both. Inside the network, we use private IP addresses that could be in any way, however you configure, or by default is 192.168.0.1212, right? But when you sign up for internet service at home, you're given a public IP. So all your equipment at home use one public IP using network address translation. So your router, as it gets the information, it sends it out to, Frontier Spectrum using that one public IP, that legal name. That's how they see you, okay? So NSA tells me, tell your student don't illegally download, because when they go through background, we know, right? So how do they know? Public IP. Public IP can be tracked in many ways. Can you spoof your IP? Sure. Like wearing a mask in public and pretend to be someone else, right? Yes, you can. However, if you gotta go through like different hoops, okay? So you have to make sure that the system sees you with the mask all the time. Otherwise, you would run into problems. So print everything calls back home, because our system is designed to log back all of the communication. So when I connect to the server respond back to me, right? It got to respond back. So that's how we're able to see communication back and forth, and that's how it can be tracked. So public IP is reserved for public domain access or public network access. Okay. Any question with this? Like I said, for the server, you can just find that on the notes, and it could just be a few. 4 or 5 hosts, you can add more to this. Could be a smartphone. So on the internet, I want you to search for some devices for small business, and then you could just add a URL. Okay. I know wireless routers is abundant, but most business use powerful router systems. And Cisco is, pretty popular, but you can just put in business router. So depending on how large or small is my network, and they can range from a few $100s to several $1,000s. So if I have a small business, I might be able to get away with something like this. And also so the important thing about routing, your media connection is very important. Like what kind of cable that connects to it, right? So if I have fiber, I want to have fiber connection on the device. If I have coaxial, like, cable internet, I would want to have that, or Ethernet, right? So most of the backbone connection now uses fiber. So when you read the description, focus on the port. The port is basically it could be a logical port or a physical port, but a physical port is just a connection point to that device. Okay, a logical port is tied to the number in the service. So now some of these have multiple functionality. You would see like, oh, it's a security appliance and a router, right? A lot of the routers can filter. So let's say that I want to use this Cisco managed, right? And then you can see that either from the vendor like Amazon. So now it says Cisco business managed switch, but this can route too, right? This is a layer 4 switching up. So the important part about the switches is how many systems can be physically connected to it. For a router, you notice that it won't have that many connection, like Ethernet connection like this, right? It will just have 1 or 2, like what you've seen in the last one. So as you find a router, you can just add the link like this. This is a VPN one and it's 150. So it's good for like home use or small business. So you want to consider the scale, right, for the type of business. Okay. So we can work on that. Now, the difference between a managed switch and an unmanaged switch, basically, you can't configure it, right? You just plug it in and it works. Okay. A managed switch would have operating system or it's iOS, like Cisco has operating system, and you can interface with it so you can configure it. So I can configure it to, use a certain connection port, right? Like port number 40. Access point. So AP is for wireless. So router, like wireless router can function as an AP, but an AP cannot function as a wireless. And then your server, you can go with like HP or Dell, or there are IBM servers, but they use a little bit different in configuration and things like that. So if you want to do like Microsoft based, there are several, right? So the purpose of this exercise is to get you used to some of the type of devices that you would see. And like I said, it really depends on how extensive you want to use, the size of your business matters, and how you shop for these devices or integrate them. So the devices in the network that uses wide area network is how it's connecting to other networks would be router, gateway. That could also be the same device, but a gateway can also be a computer, right? It doesn't have to be a small appliance. A layer 3 or 4 switch. So when we say layer 3, that's a routing layer, right? And so anything above 3 that can be routed. So whenever that you see L3 or L4, that means that that device can route. Like I said, routing is kind of like taking you on a super highway and then, taking you to the exit, right? It can let you travel across the world and to the right destination or to the street of that destination. And then the switch brings you into the network or the segment. So the router gets you to the network, the switch gets you to the segment and the system. Question. Okay, 7, we can also do this outside if we need to. I'm going to move 8 down. So a peer-to-peer network, you often see this with home, where all the systems are equivalently enrolled. Internet cafe, like LAN cafe, you see some of that. Public network, when you connect in wirelessly in the public network, like if you go to McDonald's, right? They have free wireless now. You gotta be careful with the public network because there's no one really controlling the security, right? So your data could be exposed. So when we're talking about physical and logical network in network design, the term is topology. Topology simply is a network layout. So a physical topology consists of physical arrangement and connection of the system. So for example, when you're looking at this room, the physical arrangement of this is that all the cable runs back to the wall, right? All of these desks needs to be wired to the wall, and through that they run the cable to the switch and so on. And this physical room, right, needs to be connected to maybe the server in my old office and the rack there, because that's the closest location. So they have to do some underground cabling for that, right? So it's really tied to how you physically connecting the system. Logical topology is really how data move in and out of the network. So when we're looking at logical topology, we might see that, oh, the data from the file server is going to get sent to, you know, the switches, or it gets distributed to the system via the DAT network segment. Sometimes you see physical is exactly the same as logical, but sometimes they can be different. So it is just a way that we illustrate different things. Physical topology really represents how the system is physically connected. The logical topology really represents how the data is moved or accessed across the network. I'll let you take a break after the assignment, and then we'll do the lab. The lab is really easy today, and you can also take it home to do that. Question? So let's talk a little bit about topology, because you're going to draw it. Okay. So when we say a bus, it's a straight line. Like, I'm sitting at computer 6 here, and in order to get to the computer at the end of the row, I have to connect to computer 7, computer 8, computer 9, and then to the 10. So if I'm at 6 and I need to send data to 10, it has to pass through the other 3 systems. Now the downfall of that is if this one is down, it doesn't go anywhere, right? And so the bus, it's a straight line, it's low cost, it's traditional, this is how we used to do things. If you are physically bound to that, like that's the only way that you can connect, because that's how physically your system is stationed and you can't move it and you can't add things, then you must use it. So it is easy to connect, it's easy to install, it's cheap. But the downside of this is lack in administration, lack in stability or security. When we say security, is just overall like, alternate way or recovery from if you have a downfall. Okay. And then when we say single point failure, is if I want to take out this network, I just have to target the middle system. Take this down and we're done, right? No communication, easy. So as you can see, an attacker, when they look at the network, they look at the flaw in the network. Where is the target and how they get there? It's kind of like looking at the world map, right, of a town. If I'm looking for a target in that town, I need to find the road and the highway to get to that. And it's the same thing in the network environment. how are we gonna get there and how many hurdles or security system I have to bypass to get there. So when you do ethical hacking, you have to understand how the topologies would be, the type of barriers that you are looking at, right? Because you have 48 hours to breach that system and get the things that you need and report to your client. Okay? So sometimes that's the case. Sometimes you have weeks and days. Attackers have months and days. They do a lot of research. They study. And how do they find? Well, network topology don't just show up online or things exist somewhere, right? If it's there, they can't access it. So what they do is they logically map the system by pinging or finding the system information, and that's how they map it together. A lot of the big jobs like Cedar Palace that happened not too long ago, right? MGM and all of that, there's insider definitely because there's no way that you have 12 minutes, right? I'm sure they did a lot of research for months and months end because a good attacker is a smart attacker and the one that does the homework, right? So have to have insight in order to do that kind of, wipe out the multiple networks in that group, in that company, in that short amount of time, right? So, the network technology is very, very important. Okay, the star topology is exactly as its name. It has one focal point. So like I have an HQ office and everybody connects to it. At home, you're using a star topology. Why? Your router is a hub to everything, right? In order to connect to your wireless printer, you have to use the wireless router, right? So the downfall in that, how I just attack your hub. So if I need to take down your network, and if I know that that's a focal point, just do that. Yeah. So you can add and move systems very quickly, right? Like at home, if you buy a smart device, you just connect to it, easy. IP addresses is already released, just connect to the network with SSID and authentication done. But if you have a cable connection to that focal point, let's say that you're connecting your router, right, with a coaxial cable or a fiber cable, I just go and cut your cable and you're done, right? So physical attack can happen, or if your cable is damaged, you're done. But it is easy to troubleshoot. Because you're using a lot of cables and a lot of media for the star, right? Remember that you have all of these connections coming in. Your costs will be higher. You do have a single point failure similar to the bus. In a lot of the large enterprise, the architecture really relies on hybrid star. You see star being integrated because they normally have a corporate office or a central office that control everything, right? That has the backbone and all the connection. And then eventually, it gets distributed out. Or you would see like spanning like tree type of environment. But a lot of the time they mix and match because a lot of it ties to the physical layout, the requirement, the physical geolocation, and so on. So make sure we know the difference between the bus and the star, right? If you draw a star, right, you know that there's that focal point. Any questions? And then the next one will be a ring. A ring is exactly how it sounds, right? So I take a bus and I loop it around So I'm here at 6 and I need to go to 10. Well, I just take a cable from 6 and connect them to 10. But you said, wait a minute. Each computer only have one Ethernet cable. I connect this one to this one. How is this one connecting to this one? So you have to have an adapter that has multiple ports in order to connect system to system that way, right? So the star makes more sense because, wirelessly I can connect, but yeah, I can connect this one to this one via authentication to the desktop OS, or, we can use, different protocol for physical connections. But anyway, the ring is, you take the bus and you loop it, so the 6 now have a cable connected to the 10, so it goes around. It is a little bit more fault tolerant than the bus, however, it's gonna be really slow. So you see a mesh, it's like a hybrid based environment. You hear that a lot. You ask network engineer, what kind of network do you have your work, your business? And they would say it's a mesh. So a mesh, like if you're looking at a star, right? Instead of one going to the focal point, another one going to the focal point, I can do one to the focal point, but that one can connect to the one next to it. So you just draw additional line like a mesh. Instead of just one to the focal point, I can do a second line to the next system. So it's interconnected, and yes, it costs more, right? Installation requires a little bit more, but you have more fault tolerance. So you see a lot of ring and you see a lot of mesh. A lot of the time, 99% of the time it's mesh. So when I connect one system to the next system, that's considered point to point, like a computer to a computer, a router to a router, a switch to a router, a computer to a switch, a system to a system is a point to point. But the rule is, okay, I've had students fail interview questions like this. When you're connecting a computer to a computer, use Ethernet cable, you have to use crossover. Crossover cable is not the same as the Ethernet cable that you buy at in the retail store, right? It's crossed on one end is different than the other end. We'll do that next time we meet. Next week it's gonna be holiday. So the following week when we come back, some of you will do Ethernet, and if you've done that before, you can do a coax. Okay, so when we connect the same type of devices using Ethernet cable, we have to use crossover UTP, unshielded twisted pair, the copper cable. So Ethernet cable have limitation in length, like I said, because it's copper, right? There's deterioration and also signal leak. The best type of media that you can use nowadays is fiber because it doesn't have signal leak and it's light based. So it's faster, it's more reliable, but it costs more, right? A lot cheaper than it was a long time ago. Okay, so, and when you take the coat off, they're all twisted together. That's called twisted pair because they're copper. A coaxial is also copper. This is the cheapest form of copper that they can use, and this is why internet service provider companies still love using them. And they are reliable for most part within that thicknet, but you would see this is the one with the needle, so I'll show you how you can make this when you strip it, and you would see that and then peel it and then strip it. Okay, so when you're looking at like cable TV and cable internet at home, you see coaxial. Coaxial is used quite a lot still. So Frontier and Spectrum tells you, oh, buy the fiber optic package. They tell me that all the time, right? We'll give you the throughput, but the fiber is only to your street. Understand? The older neighborhood where I live on north end of Moreno Valley. It's to the green box on my street. Okay. And then from that box to my house is this. And to my house, right? So I can connect my wireless router to coax. So it's kind of like buying a supercar, but then you only drive 30 miles per hour. Kind of sad, but I mean, it's a little bit better connection than it was long ago. But in the newer homes, they have fiber to the actual, we'll talk about that, right? The actual jack of the house. So the technician, right, for the construction company, they install all of that. Whenever you see those fiber trucks, because I drive to work sometime and I see all the new neighborhood, they run fiber all the time, right? You see the big rolls out there and they run it into the tunnel for that particular neighborhood. Okay, example, point to multiple point. Like at home, you have a wireless router to multiple computers or a router to switches, a router to multiple routers. A company doesn't only have one router, right? They have many routers because if you have one router, you're going to have congestion. You're going to have bottleneck. It's kind of like you pulling all of those cars into one exit. One road. It's going to be very tight and busy and traffic. So you might have many routers and it might connect to your one main router, or you have one router to the switches. But the simplest example is you see the switches connecting to a lot of computers. That's represent one segment, that one area of the network. So when you're designing a network or selecting the type of topology that you want to use, most business is going to tell you, make sure it's cost efficient, money, how easy it is to install, right? How easy it is to maintain. Is it going to fail? Fault tolerance requirement. And then security requirement. Now, sometimes we would waive the security because of cost, or sometimes we, so you can accept the risk because you don't want to pay more, right? You see this in life all the time. They tell you, right, you pay for what you get. That's typical. But you want to go down and check the box. For campus area network, this is CAN. And you see this when you go to UCR, university. It's a campus type of network, or if you go downtown, right? Downtown Riverside, if you go to like the city of Moreno Valley, where they have court and they have different offices, or the city or even the county area. So it really is a network that consists of systems in many different buildings. It comprises of the system that's going to share resources and data for inside and outside of the network. So if I'm connecting this building to humanities building, what cable do I use? I said this before, but fiber, that's correct. And then fiber also have limitation too, the type of fiber, right? So, a lot of the people in the island, it takes them a long time to get reliable, faster internet. But now, right, because of fiber, they're able to run fiber in the tunnel, in the ocean, to the area of, the island. So you do have like resorts that provide you with fast internet services, vacation area, or even the town for the people that live in the islands, right? So fiber changes the way that we communicate differently. But anytime that you go longer distance, floor to floor, building to building, we run fiber. Back in the day, right? Coax. And then before that, telephone. So if you go to a lot of the other country in the world that's still using like DSL and so on, they're still using telephone analog type of technology. And that's still around. So the storage area network, aka SAN or SAN, it's basically a way that we can store information or data and manage data, right? So if you go online and look for a SAN, or that's different than a network attached storage, that's gonna allow you to store your data in different scale. And backup data and data that we store is critical. You guys heard about over the summer, right? They have that bug issue with Microsoft with Cloud Strife, right? You hear about that? Where it took out all the airlines. Delta suffered the most. They got a huge lawsuit now because Microsoft. So originally Delta said, well, it's Microsoft issue because it's their updates. And then Microsoft said, no, it's Cloud Strife because that's their thing, right? At kernel level, come on now, right? So you know that's the underground structure for the OS. So they have access in that. But anyway, so Microsoft now showed evidence that they had reached out to Delta multiple times, right, to be able to support or help them get their system up to date. But their admin said, oh, we got it. And they have it screenshot. So now Delta cannot sue Microsoft for the issues that they have. A lot of times it comes down to who's going to pay for the loss, right? So all of those people who lost their flight, their tickets, refunds, all of those things, right? Compensations, all of that Delta has to pay. I heard it's like in the millions. So, and like I said, you don't have to put verbatim. Okay. So when we talk about coaxial or media, it's going to come down to this. And some of you have seen this with ATOS. ATOS talks about this too, thin net and thick net. Do you see the term 10 base 2? The number 10 in the front represents the speed. When you see 1,000 base X, 100 base X, that just represents the speed, megabit per second. So that the higher the number, the faster the connection, and the newer the technology. So in thin net, this is known as a 10 base 2. This is a thin coaxial cable. It's similar to the thick coaxial on the outside, right? Looks, the diameter is the same, but on the inside, it's different. And it uses a different connector. It uses an RG50A. So when you make your coaxial next time, you're gonna use like this. At home, right? You see the cable and then it has a screw line, and then you just screw it to the peening, right? So the needle side is the male, and the receiving side will you screw it to the peening. So this is an RG6, okay? That's the standard coaxial cable that connects to the DC. And it still is a copper core needle inside. You clean me out. That's the connector. Okay. On the thick net, this is a 10 base 5. You notice the difference? So for Network Plus, you have to remember these things, okay? This is why it's tricky, because a lot of these little technical details we have to know. So for the thick net, thick Ethernet, right? It is a coaxial, but it can go up to 500 meters. That's 1,600 feet. That's pretty far. This is why coaxial is preferred. It can go the distance and it's cheap. Yes, copper deteriorates sometimes, but it doesn't oxidize as much. This is why we prefer to use copper. And then you can have up to 100 stations connected to the cable with one tap. Okay. So any question? And you can find this also on the notes or even searching the internet. It also gives you information. So the 10, like I said, it's 10 megabit per second. So whenever that you do rate, like speed, it's bit per second. You're not saying megabyte per second. Byte is for storage. A byte represents 8 bits. Okay? So the 10 in the front means 10 megabit per second. 1,000 in the front means 1,000 megabit per second. Okay? So that's basically the speed representation. Okay. So earlier I talked about UTP, which is unshielded twisted pair. That's your Ethernet cable that you have to buy. It's the connection. The STP means shielded twisted pair. So an Ethernet cable, I'm sure most of you are familiar. It has, this is an RJ45. And this is a category 5 or 6. They're the same connector. The 6 is what we currently use. So each category we improve on how it transfer and signal at each of the wire. So on the shielded twisted pair, when you take off the cope, you see the foil. Okay. So I cut a cable. Guys, we'll do this. You take off the plastic coat and you see these little fibers there. This is for installation. You see how they're twisted together in pair. That's why we call it twisted pair, right? And you untwist it to arrange it to full connection. But on the shielded twisted pair, when you take off the coat, you're gonna see a foil wrap inside. It is better for signal shielding. So when you have a bunch of copper wire together, like in a network, if you look back at that box right there, you see a bunch of Ethernet connecting to that box, right? It's like being in a crowded room, like I said, everybody's talking loud, right? It's hard to hear one another. So when you have a lot of them together, likely that you have interference. It's like that for all of time. Okay. So in the shielded twisted pair, it is better because it shields the signal better, so you have less that you need. So in the case where you need in your network backbone, if you have a lot of cables together, it is ideal to use. Most technician and admin and engineer, we just use a lot of times unshielded twisted pair because it's just cheaper and it's more abundant, but you know, the pair in it is if you want to use or STP. So there are different type of STP. There's 10 base T, there's 10 base TX, and then there's 1,000 base TX. Okay. The number shows the speed. So as we move along, so for a lot of times I did a lot of installation for the 10 base and 100 base. And then now you see, right, much faster in speed. Question? I know it's lengthy. We'll take a break shortly. Move my Zoom bar real quick. So we touch on this, right? There it is. And then the straight through, you see 1 to 1 like this, 2 to 2. The crossover, it cross different, which is on the next one, you see? So when I have computer, I need to use crossover. When I have computer to a switch, I use a straight through, which is your regular standard, right? And there's, we'll talk about the classification for that. Here's the cat. So category 5E is what we currently use, and 6. So when I buy Ethernet connector for you guys, I normally search for 5E and 6. That's your standard 4 twisted wire pairs. So there's a total of 8 wires. And then you have other categories as well, right? Some are implemented, some are not. So it's about 20 years that we've been using Cat5, right? I've been teaching for, gosh, almost 20 years now. And I remember, yeah, talking about Cat5 earlier on. Here's RJ. So this is for telephone. It's a lot smaller than the Ethernet. People don't have landline anymore, but there's still some around, right? That uses RJ11. And then there's the 45. It's a color arrangement. There's fiber ops. So we can go 40 kilometers, that's 25 miles, depending on the type of fiber, but that's pretty good. This is why we go from building to building. And a building could be a mile away. If you're looking at the UCs, I can go from, like history building to another building that could, like engineering building that could be like a couple of miles. And if you ever visit like Silicon Valley, you go to the bigger company, they call it campuses as well. Like Cisco runs like 3 streets, 3 blocks, and it's building to building. So to wire that up, you are going to need to use cable that's going to be adequate. Okay. And fiber, if you're interested in fiber certification, I can show you the resources. You can study for that. It pays about $50 an hour to start for most part for fiber installation. There's single mode and then multi-mode, and they are different in technology. So it goes farther 50 times because the density is more. So this is glass-based. And then the LED ones, it uses multiple lights, right? So multi-mode fiber optics. Okay. Forever, right? Okay, so the frequency for Cat 5e and Cat 6, 100 hertz and 250 hertz. So Cat 6 had double it, or more than double it. So the higher frequency, the better, right? That's gonna give you more throughput. And then, like I said, you don't have to take it by verbatim. You can grab it from the notes, but I want to summarize this. So single mode fiber optic, your SMF, high speed, long distance, it uses LEDs and laser. So it is 50 times farther than your multi-mode. That's what you need. The multimode fiber, your MMF, it does the core reflection, right? This one, you can have it up to 3,000 feet, but it becomes inconsistent further along. So the majority of the time, you are gonna see single mode fiber. And the connectors are different, right? We spend a little bit more time talking about media and the connectors. So the way that, and this is, we purchase it like this, you can, so it, there are different types of fiber. The industrial fibers is a little bit more, I wanna say, not as soft that you see. This is consumer fiber. Like if you have like audio, surround sound, you see fiber cable that comes in that because you have clear quality in audio, and so on. But if you want fiber connection, you can buy them. So this is by Black Box, and they sell me the tester that we use to check. I moved the tester. Yeah. To check on how we can connect to some of the different types of connector, and it will tell you, like for duplex, this is for multi-mode compared to a single mode. So they use different connector and for different type of fiber. So they're not all the same, right? And you can probably find fiber at retail store like Walmart, Home Depot, online. And I just pulled this from the notes, so
Question.
yeah,
Are we able to access this on campus?
you will be able to access the video. I'll post the video and you can pause it. Yeah, but the notes are on Canvas. So my answers came from the notes. So if you just go to that section and you can go to the navigation tool, like here. Here's my notes right here, right? If you go to the fiber section, you can find it's right there. Okay? Everything, all the answers should come from the notes. For most part, except for the ones that we search for the internet. So if you read the notes or you go through the notes, you should be able to answer all of this. But if you watch the video, right, you can confirm it. Okay, so we would use fire distribution panel, which is known as FDP. This is where we can terminate the fiber connection to the facility, like that black box right there, right? And it consists of cable management tray, which I have an image on the note, and splice door. I think the splicing devices are a little bit better now. It's computed, and you can find the cheaper ones that's made in China. You can probably find that on Amazon for a somewhat fair price. But there are industrial, professional devices that the company will provide, like if you work for Verizon or the company that install fiber. They're designed for central offices, remote offices, and land using fiber optic facilities. So for an organization like this that didn't have fiber when I first came here, we actually contracted with a company that installed fiber. So they would run the fiber line from the street into this particular room, and it's one of the rooms that have fiber outside of the network center over there. And then they terminate it to the box right there, and they connecting the tray and the switches, so that way you're connecting on the fiber network of RCC. And then with that, they leverage that for access points for the wireless to the network, and other areas. So, you can improve one area when you add that part to your topology and the equipment, And then you can use it to leverage or lift up the connection performance for other area of your network. So FPGA used for central office or where fiber is terminated to the local area network. Okay. I know this is so long, right? But so much information. Okay, the broadband over power line. This is very common now. This is a way that we can use power connection to get high-speed data. You can find devices that do this, right? And also power over the Ethernet and so on. This is really useful for remote location that can only get power connection. We can use it in a way where we can distribute frequency so that way they can have the communication system at a high rate. I've seen a lot of countries, so when I watch shows and movies, sometimes when it shows like the street with a lot of power line and connections, right? Sometimes if it pauses there, you can see a lot of the time they run telephone line. But that area can definitely benefit from VPL and using PLC. So it uses frequency in the radio spectrum because ultimately when you're using wireless, that's frequency, right? You know, when you're flying your drone, that's frequency. I had a neighbor that was flying drone over the summer and he was recording everything. And I didn't like that because that's invading of privacy. It's actually trespassing, right? And I got upset to the point that I was gonna make a signal jammer. It's not that difficult to make, but you can go to prison for that, you know? They do sell device in China that you can do that. So basically it operates at a certain frequency, but there are professional company that does that, right? They provide the service, like when you go to stadium or the show that, you know, it blocks you from streaming from your own phone. They have a professional service for that, but they have to go through regulations to get accepted, but everything that you use electronically has some form of frequency, and in the communication, we would use the more radio band frequency. So in that, we can also have technology that allows power connection, which is electronic signal, elevate it to radio spectrum and send it over air like wirelessly. But military base, you often see that they don't allow certain type of electronic or vehicle that, you know, in surrounding area if they're operating drones, because, you know, that can prevent laser signal, strong laser signal can definitely take out some drones. Interesting. Question. And then if you miss something, we can come back. And this comes from the note, but I want to summarize this for you. The difference between CSMA-CD and CSMA-CA, this comes up on quiz and final exam and also certification. Carrier sense multiple access collision detection. So data is being sent or packets is sent back and forth. So just imagine that you have all of these shipping packages flying around, right? And eventually it's going to bump into each other, right? So packets is the same way. Communication system sending things back and forth. And for the media access control, your MAC which uses the address to your physical system. So this is a way that we can detect, right, when the transmission runs into collision. Okay. And it's gonna stop transmission in that case. So CSMA-CD is a carrier sense multiple access. I'm sorry, yeah, CSMA is a modified version of the carrier sense multiple access. All of this is basically improved performance when it detects there's a collision. It's kind of like Think about all of these cars are driving around and then eventually they're gonna bump and have an accident. But in the detection purposes, as soon as that happens, it's gonna be able to generate the signal and disperse that and reroute the car, resend different paths so that way they can get to the place safely, right? So we want to have less collision as possible, but collision occurs all the time in the network environment. And in the 90s, that happens a lot. I know this is a lot. So where can you find this? On the notes, okay? So we want to avoid collision on the network using carrier sense multiple access. This is allowing us to detect when data packets is gonna have collision, and it's going to on a wireless network or on a regular wired network. Okay. And it operates at a layer 2, which is data link, which is what using MAC addresses to the physical system. Older technology still being integrated in the network today, definitely. But I've had employers ask this questions also, because for quality of service and management, you need to understand about how collision detection occurs and how it's able to desense or be able to retransmit in case of collision. So the type of modulation, we see this when you turn on your car radio, you got AM, FM, and PM. Then anytime that you work with fiber, right? So T, the 10 base, 100 base, and 1,000 base T, remember the T? That's for twisted pair. For the fiber, you would see that it is LX. Okay. So 1,000 base LX is single mode fiber. SMF. And it still operates in 802.3 from IEEE, but is in classification Z. Now your wireless is 802.11. 802.3 is Ethernet base, right? 1,000 megabit per second. So we're in the giga these days, right? So. And then your network information service, your NIS, is a client server directory where the distributed system is configured to access files or data on the network throughout. So we'll revisit some of these areas more closely, right? Overall, today we kind of hit all of those things, what network's about, topology, and so on. I gotta reduce this for future purposes because I think it's too long. Focus. Need a break? Okay, if you need breaks, make sure if you need to use the restroom, I think they usually close the restroom around 8-ish when we're done, but restroom is right here. When you come out, it's on your right side. If you want some snacks, I have some snacks up here. Water, I think there's a water fountain down that way or on the side over here. But let's say 10-minute break. I'm gonna end the video and then I keep the lab separately.